So I'm going to do an F5, and now it's telling you what is the third peak energy, and I'm going to take my second peak of my cobalt,
Yes.
1332 approximately. I will say OK. Go into the unexpand mode, so I can see my final peak. Go to the vicinity there, expand, by pulling the cursor to approximately the centroid channel, and then I do an F11. And now I can say F11 to accept. So now I believe it is calibrated.
So
okay. Now if I move my cursor around, I should be able to see, like this is telling me 87.8 keV. Second peak should be approximately 662. This one should be about 1100 something, and this is 1332. So now after it's calibrated, I can go in there to the regions of interest that I have drawn in here, and I can go and
expand.
put myself in the ROI, and immediately I'm going to see my values. So I can see that my 1332 peak right now is showing me a centroid position of 1332 keV integrator count, and the most important number that I'm interested in here is to see my full width half maximum peak resolution to about 1.710 keV, which I know is good because my detector is spec for around 1.8 keV. So I am actually doing better than the specs of my detector. So do you think this is a good number, Daniel?
Very good.
1.710 keV. I can accept that. If I am interested to look at the energies in other channels, I can do the same thing. I can go into unexpanded. Let's say I want to see the resolution of the cesium peak, which should be even better. I can go to the vicinity of the cesium peak. I can do an expand.
Make a ROI.
Make a region of interest. Shift key. Select the left boundary. Move to the right boundary while pressing the shift key. And now I have a region of interest. Once I set it up, automatically you can see that my resolution here is 1.373 keV for the cesium peak. Okay, if I do an unexpand, you can see in the context of where I am. Here you can see my resolution is 1.37, which is very good for this detector. And here I can see my resolution for the 1332 cobalt, which is usually what, according to the ANSI standards, the detector manufacturers will specify their peak energy resolution is based on the cobalt 60 peak is about 1.71 keV. So I think my setup parameters for the MCA is fairly good. Do you agree?
Yes.
So what I'm going to do is I'm going to go ahead and save this file, and I'm going to call it save as, and I'm going to say setup file. I will do OK, and instead of calling it junk, I'm going to say MCA setup. Okay, 1 of this date, and I will save it. All right. Now I can acquire spectrum, but because of the analysis work that I'm interested in, I'm going to do the analysis work through another video. So in order to do the analysis work from another video, what I'm going to do right now is I'm going to go ahead, I'm going to go to my setup, I'm going to go to my high voltage, I'm going to turn my high voltage off because I will install spectral line on the other side. Sorry, put it 0. I will say OK, and you can see the high voltage start to ramp down. You can see the high voltage icon becomes solid, red light here, and then as it's blue, it's ramped down. Then I will go to my file, I will disconnect the MCA. The MCA is disconnected. Again, it's important that you went to the file and you turned off the high voltage.
Disconnect.
From here, high voltage should be 0. And you go to the file and you go to disconnect, because I already disconnected. You can connect or disconnect. You disconnect the MCA and you close it. End of this video.